Hello there. In this video, we'll be solving worksheet problems on complex number. Don't forget to subscribe, like and comment for more videos. The first question, given that a plus bi, it's a complex number, is equal to 2 plus I, the whole over 2 minus 3i. Then find a square plus b square. This is what we need. There are two complex numbers here, left hand and right hand side. They are equal. So what to do? Let us try to write the right hand side in a standard form, in the form of x plus yi. Then we can equalize the real part with the real and the imaginary with the imaginary. So for that matter, let's multiply the numerator and the denominator by the conjugate of the denominator, that is 2 plus 3i over 2 plus 3i. When you multiply by the conjugate of the denominator part will be real. So let us multiply. When you multiply, what will happen? 2 times 2, you can expand. 2 multiplied by 2, 4, and 2 times 3i will be 6i. Again, I times 2 will be 2i. Again, I times 3i will be negative 3. So 4 minus 3 will be just 1. Again, 6i plus 2i will be 8i. Done. The upper part. The lower part, when you multiply a complex number with its conjugate, it will be the square of each. So 2 square will be 4 and 3 square will be 9. This is 9. So this is equal to a plus bi is equal to, when you add these two, it's going to be 13. So I can write it 1 over 13 plus 8 over 13 I can give the denominator for each. This time it will be simple to make real with the real and imaginary with imaginary, but we need to find a square plus b square. So I'm going to square each. So 1 over 13 square plus 8 over 13 square. When I square each, 1 over 169 plus 64 over 169. Since the denominator is the same, I can add the upper part, which will be 65 over 169. This time I can simplify further. 65, it is 5 times 13, and the denominator is 13 multiply 13. So what I can do here, I can cut the 13. So finally our answer will be 5 over 13. This is a square plus b square. The next question, x plus yi, the whole over 2 plus I is equal to 2 minus I cube. We need to find x and y. So what to do? We can multiply crisscross. X plus yi is equal to, when I multiply this one, the crisscross part, 2 minus I cube times 2 plus I remain. Here we need to be systematic. 2 minus I cube means 2 minus I times 2 minus I times 2 minus I. But the last product, this one with this one, since they are conjugate of each other, simply the product will be here 2 square plus 1 square. The product of a complex number and its conjugate will be the sum of the square of each component. So it's going to be 5, just 5 remain. So we need to multiply only these two. The product of these two will be 2 times 2, 4, and 2 times I is negative 2i. Again, this I will be expanded, negative 2i, then minus 1. The second bracket, just 5. So this is equal to 4 minus 1 will be 3, minus 4i remain. Multiply with 5. When you multiply and finalize, 15 minus 20 I remain. This is x plus yi. Once we arrived here, we can take the real with the real and imaginary with the imaginary. X is equal to 15 and the y value is equal to negative 20. That's the answer. Next question, x plus yi in bracket I plus 2 minus 3 is equal to 2x minus 3y plus 7i given. Let us try to remove the bracket here. Let's expand it. Xi plus 2x minus y, when you multiply with the y again, yi times I will be minus y, because I times I square, plus 2yi, let's write it properly, 2yi minus 3 is equal to 2x minus 3y plus 7i. Don't forget, we are asked to find x minus y. So what I can do here, the left hand side, let us collect the real together. This one and this one are real. So 2x minus y minus 3, the one which has no i's, are real. The imaginary part will be x plus 2y, the whole I, is equal to 2x minus 3y. Again, the real part to the right side, these together, plus 7i. Now we can equalize real with the real and imaginary with the imaginary. Is the whole thing with this. So 2x minus y minus 3 is equal to 2x minus 3y. This time again we can cancel 2x with 2x, and then I can bring this negative 3y here. What remains? 2y, which is equal to, the 3 can be shifted to the right, will be 3. So the y value will be 3 over 2. We got it. This is a y. What about the x? To get the x, again we can equalize the imaginary with the imaginary. Here the imaginary is, here it is, equal to 7. So x plus 2y is equal to 7. X plus 2 times the y value is 3 over 2 is equal to 7. You can cut the 2. So x is equal to, when you shift 3 remain here, when you shift it, it will be 4. We have got the x value also. But what is asked? We are asked to find x minus y. So x minus y will be, the x value is 4 minus 3 over 2. When you apply crisscross, 8 minus 3 will be 5 over 2. This will be the answer. The next question, what is the coefficient of x cubed? X plus 2ii, the whole the power of 6 will be expanded, and then the coefficient of x cubed asked. So when you expand a plus bi, the whole the power of n, to find the coefficient of any term, we can apply the combination rule, and the combination are the whole times, not a plus bi necessarily, any, just a plus b we can take. So a the power of n minus r times b the power of r. This is the formula. So let's apply this. Our n is 6 here, so we need 6 combination. Since we are asked the exponent x the power of 3, 6 minus 3 will be 3. So 6 combination 3 times x the power of 3, again 2i the power of 3, because 6 minus 3 will be 3. Our r is 3 here. What is 6 combination 3? 6 combination 3 will be 6 factorial over 6 minus 3 is 3 factorial times 3 factorial, which is 6 times 5 times 4 times 3 factorial over 3 factorial times 3 factorial. So we can cancel 3 factorial here. 3 factorial means 3 times 2, which is 6. So this 6 will cancel this 6. So what remain? 20 remain. So I can write this whole part, and I can write 20. In place of 6 combination 3, I can write 20 times x cubed, again 2i the power of 3, 2i times 2i times 2i. 2 times 2 times 2 will be 8, and I times I will be I squared, that's negative 1. Negative 1 times I will be just I, but the negative remain here. So I do have negative 8i. So the product will be negative 160 I x cubed remain. But we are asked the coefficient. The coefficient means the number in front of x. That number will be negative 160. I will be the coefficient number. Next question. What the value of x and y, so that 1 plus 3i the whole over 2 minus I times x plus 20i is equal to 30. So what am I supposed to do here again? I'm going to multiply by the conjugate of the one which is in the bracket, that is 2 plus I over 2 plus I. Let us use our space properly. We'll multiply by 2 plus I over 2 plus I, the conjugate of the denominator part. Don't forget there is x outside here. So we need to find x value and y value. Then when you multiply, what will be the result? The result will be 5 plus 5i, the whole over 5. When you multiply these two, they are conjugate of each other, so the square of each. 2 square plus 1 square will be 5, and the upper part 1 times 2i, and then you'll expand and then you'll get this result. This denominator 5 is for each of them, so it will be simplified and it can be written 1 plus I times x plus 20i is equal to 30y. So again, let us expand and collect the real with the real and the imaginary. The imaginary, this x will multiply each of them, so x plus xi plus 20i is equal to 30y. That means the real part is just x, which is equal to, here the imaginary part is x plus 20. I is equal to 30y. Therefore, left hand side, the real part is just x. The right hand side, the real is, this one is x, and this 30y is a real part. Here this is not equal, this is plus. So the real with the real means x is equal to 30y. The other one, here the imaginary x plus 20, the left hand side the imaginary is 0, so x plus 20 is equal to 0, so x value is equal to negative 20. Keep it. We have got the x. What about the y? Negative 20. Let us change the color to make it more visible. Negative 20 is equal to 30y. From here, in place of x, I substitute negative 20. So I can divide both sides by 30. Therefore, the y value will be, you can cut the 0 here, negative 2 over 3. So this is a value of y, and this is a value of x. Done. Next question. The modulus of 5z over 1 minus 2i is equal to 2 plus I times the conjugate of 2 plus I. Then we are asked what is the modulus of z. So this time, the left hand side, we can give the modulus for up and down. 5z over 1 minus 2i modulus each of them is equal to, this is conjugate, it will be 2 plus I times 2 minus I. The conjugate of 2 plus I will be 2 minus I. Now the right hand side is just a constant, because when you multiply the two, they are conjugate of each other. It's going to be 2 square plus 1 square, that's 5. And the down part here also, the modulus of this one will be 1 square minus, modulus of 1 minus 2i will be square root of 1 square plus 2 square. That is radical 5. Here also this constant can be extracted. So what remain? Let's write it with somehow different color. So what I have in the numerator, 5 modulus of z, the whole over square root of 5 is equal to 5 remain. The right hand side also, when you multiply, it will be this result. Then by crisscross, what I can have now, 5 times the modulus of z is equal to 5 radical 5. So if you divide both sides by 5, then what remain? The modulus of the z will be, you can cut the 5 here, radical 5. So that is the answer. Next, we are given the complex number z, which is cosine of pi over 10 plus I times sine pi over 10. And then we are asked to find z the power of 5. There is no r here, the r is just 1. So z to the power of 5, which is equal to, it can multiply, this exponent will multiply the coefficient of the theta. So cosine of 5 multiply with pi over 10 plus I times sine of 5 times pi over 10. If there is a constant here, like if there is r, that's going to be an exponent. If there was r here, the 5 will be the exponent of that r, but there is no r here. Therefore, this will be, when you simplify by 5, to cosine of pi over 2 plus I sine pi over 2 remain. Pi over 2 is 90 degrees, so cosine 90 is 0, and sine 90 is 1, so just I remain. So the answer finally will be only I. Next question, we are asked to simplify the modulus of 3 plus 4i is equal to, minus 25i over 3 plus 4i. What am I supposed to do here? This one, the modulus, simply square each in the square root. That's 9 plus 16 in the radical, 25, that is 5. So this part is just 5. Minus the other side, I have to multiply by the conjugate of the denominator, 3 minus 4i over 3 minus 4i. When I multiply 25, don't forget this minus, keep it as it is. Here it is already written, but I'm going to multiply without the negative. 25 times 3 will be 75i minus plus 100. The whole over, the down part will be 3 square plus 4 square, that's going to be 25. This 25 will be given for each of them, the denominator for each. So 75 over 25 will be, 3i plus 4. Then this is going to be 5 minus 3i minus 4. So what I can have, 1 minus 3i. That is the simplest form, because these two are real. 5 minus 4 is 1, so 1 minus 3i will be the answer. This is the answer for A, the first part. Okay, let's do the second part here. Let us use this space. The second part, 4 minus 3i, the whole over 3 plus 4i, plus 1 minus 2i conjugate. So what I can do here again, I can multiply by the conjugate of the denominator, 3 minus 4i over 3 minus 4i. When you multiply, 4 times 3, 12, minus 16i, minus 9i, minus 12. The whole over, the down part is 9 plus 16, which is 25, plus the conjugate of this one will be 1 plus 2i. Then 12 will be cut out with 12. What remain here? Negative 25i over 25 plus 1 plus 2i. Again, we can cut 25 with 25. What remain? Negative I plus 1 plus 2i. So what I have? 1 plus I remain. Because negative I plus 2i will be just I. So the constant, the real part is 1. So 1 plus I will be the simplest answer. The next and the last question for today, it says z cube minus iz is equal to, find the solution set of this is equal to 0. It should be is equal to 0. So what to do first? We can take out the z common, z into z square minus I is equal to 0. So one of the solution set is z is equal to 0. This is one answer. The other solution, d square minus I is equal to 0. But what is z? It's a complex number. So in place of z, we can take any x plus yi. It's a complex number. So x plus yi, the whole square minus I is equal to 0. Let's expand it. This will be x square plus 2xyi minus y square minus I is equal to 0. We can expand this and you can check it. So the real part here will be x square minus y square plus 2xy minus 1i. These together are imaginary, is equal to 0. As you see here, the real are only these two, the imaginary are these two together. But the coefficient here 1, that's why 2xy minus 1. So I have two equations here now. This sum is equal to 0 means 0 plus 0i. So x square plus y square, x square minus y square, which is equal to 0. From this we can say x square is equal to y square, keep it. The other part, 2xy minus 1 is equal to again 0. From this, 2xy is equal to, you can shift 1, then divide by 2x both side, and you can express the y. Y is equal to 1 over 2x. Okay, very good. Now we can bring this one in place of y. So x square is equal to 1 over 2x the whole square. So what I have now, x square is equal to 1 over 4x square. Again by crisscross, 4x power of 4 is equal to 1. Okay, I have this one. Let's go to the next page and let us proceed. So we have 4x power of 4 is equal to 1, divided by 4 both sides. So x power of 4 is equal to 1 over 4 means if you put in the square root both sides, x square is equal to plus or minus, so 1 over 2, or x square is equal to negative 1 over 2 I have. Still I have to put in the square root both sides since it is on the set of complex number. So x value 1 over radical 2 means root 2 over 2, that is plus or minus, to answer it as. So again x is equal to plus or minus radical 2 over 2i. There is I here because the number is in the square root. So x value has 4 answers. What are they? X is equal to radical 2 over 2, negative radical 2 over 2, or root 2 over 2i, and negative root 2 over 2i. Either of the 4 will be the value of x. What about the y? Since we express the y value, y is equal to 1 over 2x, we can substitute. If you substitute, for example, first one here, in place of x, what you'll have? 1 over 2 times radical 2 over 2. So when you cancel it, what left? 1 over root 2. 1 over root 2 means again root 2 over 2. So it will have the same result the other words. Also it goes in the same pattern. So we can finish it in this way. Don't forget to subscribe, like and comment. Hopefully I'll get back with additional questions. Thank you for watching.